Hello, today we're going to be talking about the metric system and measuring. Before we go further, let me remind you that slides with a red background are slides that you're going to have to take notes on, so make sure you have your notes page handy as you're watching the video. And don't forget to look for the owl, because at the end you will have to describe where the owl is, and don't forget you all also have to write a 2 to 3 sentence summary of what you learned in this video. Remember, you have to do all of those things in order to get full credit for this homework. Okay, so let's talk about what the metric system is. Well, basically this is a measurement system that is based on powers of 10. This is an interesting map right here. This shows countries that do not use the metric system. The countries that are highlighted in red here are the only countries in the world that don't use the metric system. And you can see that the United States is one of them. We've been kind of stubborn about using our own system, but I'm hopefully going to convince you that the metric system is better and easier to use than the system that we currently use in the United States. So let's take a look at the system that we use here. I'll give you a couple examples of where some of the familiar measurements that we use in the United States came from. So here's one. An inch was originally based on the width of a person's thumb. A yard was based on the distance from somebody's shoulder or from their nose to the tip of their arm. That's a normal person's arm span. A foot, well, that's not too hard to figure out. That was based on the length of a person's foot. A mile was originally the length that the Roman army could march in 1,000 paces. But it seems to me like there's maybe a little bit of a problem with some of these units. Can you think of anything? Well, take a look at these pictures. I mean, is everybody's foot the same size? Is everybody's thumb the same size? Does everybody march the same distance in 1,000 paces? So we needed to get a little bit more specific and have standard units that are the same for... Oh, hi Yoda. So, okay, I got it. We're going to have to unlearn what we have learned. Yes, okay, Master Yoda. Quick question. What's bigger, 1/2 or 5/8? Well, I don't know about you, but fractions aren't always that easy for me. I would much rather the top system that is just going 8, 10, 12, 13, 14, 15, 18. A lot of times that's easier to figure out which one's bigger and which one's smaller. With the system that we use in the United States, a lot of times things like tools and that kind of stuff is done using fractions of an inch, and that can be really tricky sometimes. So that's one of the reasons why I think that the metric system is probably a better system. But, oh, hey Yoda, metric system is stronger because it's based on the number 10. Oh, okay, I get it. So yeah, 10s are kind of easy, right? Yeah, 3 times 10 is 30, right? Okay, 30 times 10, that's 300, right? And 300 times 10, that's 3,000. Okay, I get it, I get it. Yep, 30,000. And 30,000 times 10 is, well, that's 300,000, and that times 10 is 3 million. Yeah, this is really easy, right? We're just adding on zeros. Multiplying and dividing by 10, generally speaking, is pretty easy. You're just kind of adding or taking off zeros, or we could think of it that you're kind of moving the decimal place around. All right, so multiples of 10, that's pretty easy. I like that. But it's good to have an intuitive sense of what these measurements really mean as well. In the same way that you kind of know about what an inch is, you could take your thumb and your finger and space them apart about an inch and be pretty accurate. You know about what a foot is, and you know about how long a mile is and things like that. So let's take a look at this picture here. Well, we have in the top picture, you see 1 centimeter, and you see that that's divided up into 10 millimeters. So we have 1 centimeter from here to here, and we have that divided up into 10 millimeters. And a millimeter is probably a good way to think of that is that a millimeter is about the thickness of a dime or so. A centimeter, well, that's 10 of those, and that's maybe about the width of your pinky. It equates to being about 1/2 inch or so. That's 1 centimeter. Now, if we look at the next one down, we can see that there are 100 centimeters in a meter. So a meter is 100 centimeters, and that's similar to what we think of as something like a yard. So if you're familiar with football, you know about how much a yard is. A meter's about the same length. And then finally, we have 1,000 meters makes up 1 kilometer. And a kilometer we could think of as being kind of like a mile. It's probably closer to something like a half a mile, but it's kind of a long distance. Oh, okay. Hi, King Henry. Looks like we got a lot of guests for this video today. So, okay, you love chocolate milk. That's great. Oh, oh, okay. Oh, well, what happened? Okay, King Henry died by drinking chocolate milk. Okay, I see. This is a way of remembering the order of metric prefixes. So these are going to go in front of the unit you're using. So if you're measuring length, you would be using, say, the meter, for example, and these will go in front of that word meter. If you were measuring something else like liters, like a 2-liter bottle of soda or something like that, it's going to go in front of that word liter. So you could have something like a kilometer or a kiloliter. And so this is the order that they go in. So they go kilo, then hecto, deca, and then the base, which means just the word by itself, like meter just by itself, not with anything in front of it. Deci, centi, and milli. So these are the ones that I'm going to want you to know about. So the ones that I just showed you, those aren't all of the prefixes that exist, but they're the ones that you're going to need to know for this class. But I think if you look at this list here, you can see that there are some more that you're probably familiar with, like mega, giga, and tera. You've probably heard of those because those are ones that we use in computers a lot, megabytes, gigabytes, and terabytes. And we can go all the way up to yotta. Not you, Yoda, Yota. And we can use these to measure things that are really big and measure things that are really small. So we have the really large numbers up here, so we can measure things like stars and distances in the universe and things like that. And we have the really small, so we can measure really, really small things. And we're going to be doing a lot of that in class, measuring the size of atoms and things like that. So let's talk a little bit more about the idea of converting from one prefix to another prefix. Remember, the main idea here is all you need to do is sort of move decimal points around, or think of it as adding on or taking off zeros at the end of the number. So this is a picture of an average person. And again, I really want you to get a sense of what these units really mean. So like, how big is a meter? Well, you can see that we have an average person here, and we have a meter stick. And if we put a meter stick next to a person, I would say it looks like the average person is probably about 1 meter plus another half a meter or so. So we could say that the average person is about 1.5 meters. So most likely you're probably somewhere in that area, somewhere between 1 and 2 meters. Something like 1.5 meters is probably how tall you are. So how many centimeters is that? Well, remember that there's 100 centimeters in each meter. So from the ground up to here, this first meter, well, that's 100 centimeters. And if we went all the way up to the top of this second meter stick here, that would be 100 plus 100. Well, that would be 200 centimeters, right? But we're only halfway up this one. So, well, think about it. What's half of 100? That's 50, right? So if we have 100 plus 50, then that would be 150 centimeters. That wasn't too hard, but I want you to notice this as sort of a math problem and look at the comparison between the two numbers. We have a 1 and a 5 in our meters measurement, and we also have a 1 and a 5 in our centimeters measurement. So you can think of this, so we're just kind of moving the decimal point around. We move the decimal point from in between the 5 and the 1. to over to the right 2 spaces, as you can see by the arrows down at the bottom here. Now, if you look up at this cheat sheet that I have up here for you with King Henry died by drinking chocolate milk, you can see that we also had to move 2 spaces, 2 steps on our sheet here. So we went from the base, meters. Remember, base means you don't have anything in front of the unit that you're using, which in this case is meters. So that's our base, and we had to go 1 step down to deci and a 2nd step down to centi to get from our meters to our centimeters. So we moved 2 steps up here, and we moved the decimal point 2 steps down here. So this is a way of figuring out how to convert from one unit to another. So let's try another one. Well, if you're 1.5 meters, we already saw that you're 150 centimeters, but how many kilometers would you be? Well, okay, first of all, this picture here is not quite right because that makes it look like you're maybe about a half a kilometer or something, and you're definitely not that. Remember, kilometers are something like a mile, and I don't think you're half a mile tall, right? So maybe it should look more like this guy down here, and even that might be a little bit too big. So, okay, so how did we do this again? Well, we're starting at meters, our base, again, and we need to get all the way up here to kilo. Remember, we started with meters, and we're moving our way up to kilometers or kilometers. So how many steps do we have to go? We have to go 1, 2, 3 steps. So remember, we're going to need to move the decimal point 3 spaces. But let's think about this for a second. If we move it 3 spaces this way, 1, 2, 3, and fill in our zeros, that would be 1,500 kilometers. That doesn't make sense. I mean, I think if I said to you that you're 1,500 miles tall, you would understand that that doesn't make any sense. Well, it doesn't make any sense here either. And so the problem here is we went up 3 steps this time, so we're going to have to move the decimal point to the left instead of to the right. And because we moved 3 spaces, we're going to move the decimal point 3 spaces to the left. So we're going to go 1, 2, 3 spaces to the left, and so we get 0.0015 kilometers. And to just think of that in a very simple way, that means you are way less than 1 kilometer tall, right? And that kind of makes sense. You are way less than 1 kilometer tall. So basically you can think of this like moving up and down steps. We start with whatever unit we want to start with, like the base unit, or maybe we want to start from centimeters and go to millimeters, or maybe we want to go from kilometers down to meters or something like that. And all we have to do is count how many steps we go down or how many steps we go up. And just like this picture, if you go up the steps, you are going to move your decimal point to the left. And if you go down the steps, you're going to move your decimal point to the right. Exactly. Thank you, Yoda. And so let me show you a little animation on the next screen here to kind of reinforce this a little bit. Okay, so now we've gotten the basic idea of the metric prefixes and how they work. Remember, it's just about multiplying and dividing by 10, which should be pretty easy. So let's talk about what types of units we use to measure different things, and let's try to compare them to things that maybe you're more familiar with. So if we start off right here, we can see that in America, maybe we would buy a pound of butter, but if you were in, well, almost anywhere else in the world, you would be more likely to buy butter in kilograms. So we can see the base unit here. We see our kilo right here, and we see our gram here. So you can figure out that gram is kind of something like a pound. It's a similar idea. We're measuring the weight of something or something like that. Over here we have quarts. Sometimes we buy milk in quarts in America, but everywhere else they buy their milk in liters. Now, I think we're kind of familiar with that because we know about 2-liter bottles of soda and that kind of stuff. But what exactly are we measuring here? Well, in this case, we're measuring an amount of stuff, like how much milk, how much space does that take up? That's what we're measuring with those units. And we've already talked about the idea of measuring length. And you know that in the United States, we measure length in feet, yards, inches, miles, things like that. But everywhere else, they're going to measure things in meters and centimeters and kilometers. And you can see that a meter is pretty similar to a yard here. One last thing, and that is temperature. In America, we use Fahrenheit, degrees Fahrenheit, but in most other places, they're going to use degrees Celsius. And a couple really important things to know about the Celsius scale. It's based on the temperature at which water freezes and the temperature at which water boils. And you can see that there's some pretty easy numbers to remember here. Water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. Again, using multiples of 10 here. Much easier to remember than 32. You might have that one, but water boils at 212 degrees Fahrenheit. Did you know that? Your normal body temperature is 98.6 degrees Fahrenheit, and that would be equivalent to about 37 degrees Celsius. So because this is used pretty much everywhere in the world, this is a system that is a lot of times referred to as the International System of Units, but that's really just another name for the metric system, and it's abbreviated to SI. You might wonder why SI and not IS. Well, that's because they came up with this name in France, and in France they kind of say things a little bit backwards than what we say it in the United States. So, what I want you to see here is the quantity or the type of thing that we're measuring. Are we measuring length? Are we measuring how heavy something is? Are we measuring how bright something is? That kind of thing. And then we'll see the unit that is used for that, and we'll also see the abbreviated symbol for that unit. So make sure you're filling these in as we go. For length, as we already know, we use meters, and the symbol for that is M. For mass, which is kind of like weight, we use something called grams, and the symbol for that is G. The metric unit for measuring time is actually the same thing as what we use. They use seconds and minutes and hours, just like us, and seconds is abbreviated with an S. Electric current, this is something we'll learn about in class later on. Electric current is measured in amperes. The letter for that is A. Temperature, there's actually two different units that they might use depending on what you're talking about, and we'll go over both of these, but the two different units are Kelvin and Celsius. The abbreviations for those are K and C. Light intensity. This one's not really too important, but the official unit for that is the candela, and the abbreviation for that is CD, and the amount of a substance. And we'll talk more about that later, but this usually comes into play when you're actually trying to count exactly how many atoms you have of something. And that's called a mole, and that's abbreviated MOL. So a couple more that we need to add on to this list that I forgot about in that other list. So one really, really important one that we're going to use a lot is liquid volume, and that's basically how much space does that liquid take up. And as we talked about before, that is liters, and the abbreviation for that is L. And another one that we're going to talk about quite a bit in class is force. And the unit that we use to measure force is a Newton, and the abbreviation for that is N. That's, of course, named after the famous scientist Isaac Newton, who came up with a lot of ideas about how forces work and things like that. So that's it for today's lesson. Make sure that you get all of those notes filled in. Make sure you show me where the owl was and write a brief description. Remember, if you need to go back, you can always rewind. You can always pause whenever you need to. So today we learned about the metric system. We learned that it is based on powers of 10, and hopefully myself as well as Yoda helped you to convince you that this is an easier way of doing things and makes a little bit more sense. Remember that when you are multiplying and dividing by 10, it really means just moving a decimal point around. That's pretty easy as far as math goes. We learned the prefixes and the easy way of remembering it. King Henry died by drinking chocolate milk. Tragic for Henry, good for us. The decimal point moves left when you are going to a bigger unit. It moves right when you're going to a small unit. We learned about the different base units for each type of measurement. 1 unit for each type of measurement. That's really important. Meters for length, grams for mass, and so on. And this is what we are going to be using in science all the time. So get used to it, whether you like it or not. See you next time.